Hello and welcome to this episode of Night Sky News for April 2025 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about all things James Webb Space Telescope, from the announcement of the observations JWST will be making in the next year, to how it spotted Neptune's aurora for the first time, to the images it's captured of the no longer hazardous to Earth asteroid 2024 YR4, and JWST's discovery of the new record holder for the most distant detection of glowing hydrogen in the early universe. Plus, I've got some new merch to announce, including this JWST planets design that I'm wearing at the minute, so stick around to the end to hear more about that. There's also chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. Alright, first up, this month you might hear people talking about the Lyrids meteor shower, which this year is peaking on the night of the 22nd of April into the morning of the 23rd of April. It's a fairly average meteor shower with anywhere from 10 to 20 meteors per hour, so shooting stars, streaking across the sky, caused by just tiny lumps of space rock burning up in the Earth's atmosphere. So that's only a shooting star every 3 or 4 minutes or so, which is why, with so few meteors, this is just kind of like an average shower. It can be a bit hit and miss whether you even see them, depending, on how dark your sky is. The darker the sky, the more you're likely to see, because you'll see the faint ones as well. Although this year the moon is only just a sliver of a crescent on that night, so there'll be no bright moon to wash out any of the fainter ones. To have the best chance of seeing meteors, you want to be out around about midnight if you're in the northern hemisphere, or in sort of like the wee hours of the morning if you're in the southern hemisphere. So if you are planning to get up early, whether that's to spot meteors or not, then why don't you also look out for Venus and Saturn in the east before sunrise. The further south you are, the better chance you'll also have of spotting Mercury much closer to the horizon as well. Plus, on the morning of the 25th of April, my favourite, the crescent moon, aka the toenail moon, will come to join the party. The closer you are to the equator, the better for this one, as those of us a bit further away from the equator, like me up north, will struggle to pick this out low on the horizon in the glow of the early morning sunrise. So unless you're getting up that early anyway, I wouldn't make a special effort to do so unless you are closer to the equator. And speaking of being closer to the equator, there's also the Eta-Aquarids meteor shower, which peaks this year on the night of the 6th of May and into the morning of the 7th of May. This is a much more spectacular meteor shower than the Lyrids meteor shower, but the further south you are for this one, the better. And that's because the radiant, which is the place in the sky where all the meteors appear to be streaking away from, will be much higher in the sky in the southern hemisphere. So you should see up to 60 meteors an hour in dark skies. Whereas up here in the northern hemisphere, it will be closer to the horizon in the southeast. So we're actually going to lose half of them as they streak below the horizon. So that means only 30 meteors an hour. So that's, one every 2 minutes or so, at least in the darkest of skies. But what is fun about spotting a meteor from the Eta-Aquarids meteor shower is that all these little lumps of rock that are burning up in the Earth's atmosphere are debris left over by the famous Halley's Comet, which I always think is a nice fun bit of trivia. And if you are going to make a night of watching the meteor shower, then just remember it is a bit of a long game. It's a waiting game, so bring a blanket to lie down on or a chair to sit on and just get comfy. You don't need any specialist equipment, you don't need a telescope, you don't need binoculars, you just need your eyes. But remember, they are sort of like a blink and you'll miss it kind of situation because of how fast that they streak across the sky and sometimes how faint they are as well. So the more people you have together watching the meteor shower, looking out for things, the better. But if you are stargazing 2 weeks either side of the 7th of May, so 2 weeks before, 2 weeks after, before is a good idea. I know because it's a bank holiday weekend here in the UK, so people might be traveling somewhere dark, somewhere remote. If you see a shooting star in that period of time, most likely it's from the Eta-Aquarids meteor shower. Now, you might remember that in last year's Night Sky News for April, I talked about the star T Coronae Borealis, which we think could go nova at sometime soon. And you might have seen this reported more in the media in the past few weeks, as how a new star might appear in the sky, which is technically true, but let's first just rein in those expectations of what that's actually going to look like, and then chat about why this has been popping up in the news again and on your social media feeds now. So in this area of sky, in the constellation of Coronae Borealis, there's a star right here that normally you cannot see with your naked eye. It is fainter than Neptune. But 80 years ago and 80 years before that, the star had a little mini explosion where it got a lot brighter, and we call this a nova. If it does that again around about now on this 80-year cycle, then yes, it will become visible with the naked eye, even from like the suburbs of a city. However, it is not going to get so blindingly bright that it will be so obvious in the sky. We're talking about, say, as bright as the stars in the constellation of Cassiopeia, the W. So here's the thing. If you're not familiar with that part of the sky where you have the constellation of Coronae Borealis, you're not going to notice if one more sort of bright, sort of faintish star pops up. If you just look up, it's just going to look like stars. So if you want to be able to spot this, when it does happen, you need to do some astronomy homework, right? You need to get really familiar with that part of the sky. You need to figure out what direction you need to look for it from your house's back garden or from the balcony or of your flat, whatever, wherever you're going to actually look at the sky from. You need to figure out, okay, what can I normally see, so that if it does happen, you're actually able to, spot the difference. But the reason that this keeps popping up again in the news is because us astronomers keep making inaccurate predictions of when it's going to go nova based on all of the historical data that we have for it. So yes, it was observed going nova in 1787, 1866, and 1946 on this roughly 80-year cycle, meaning it is going to go nova again soon. We just don't know exactly when. So some people predicted it would be last summer after it dipped in brightness like we saw before the last nova in 1946. That was the prediction from this paper by Schneider, who estimated these dates based on all the previous observations that we have. The August 2024 date last summer obviously came and went, and the hype ramped up again for the 27th of March 2025 date this month. But sadly, once again, that date came, no nova.
Christmas came. No weenie whistle.
So the hype will most likely die down again a little bit over the summer if, nothing does pop up. Probably build again around that November 2025 date, and then crop up again in June 2026 if there's still no activity by that point. In the meantime, though, do your homework, find Coronae Borealis in the sky from your house, and commit that part of the sky to memory. While you're there, you might as well check out the planets as well, because we've still got the reddish Mars and bright Jupiter hanging around in the evening sky for a bit longer. They're right by the constellation of Orion, which as the days crawl on into May is going to set earlier and earlier until we lose it from our skies until next winter. So spot it while you can. Similarly, Jupiter won't be around for as long after sunset as we get into May, although given how bright Jupiter is, it's still visible in that sort of glow after sunset, which makes it a really pretty sight. The best time to look out for Jupiter and Mars this month, though, is when the crescent moon will also be in that part of the sky, from the 30th of April when it's closest to Jupiter and up to the 3rd of May when it's moved closer to Mars. If you're not sure what you're looking for, though, for either the planets or for Coronae Borealis, you can always download a star chart for your location from the internet. But before you do that, you should make sure you're protected online thanks to Surfshark, the sponsor of this week's video. Surfshark is a VPN, a virtual private network, and it's essentially a middleman between your computer and the scary internet, which means that your private information, your location, and what you're doing is all hidden from anybody who happens to be snooping. Surfshark is crucial for me as an academic because I'm always working on public Wi-Fi networks, whether that's in my office or in the university library or when I'm traveling for work. It means that no one can snoop on my, unreleased research paper, but also my credit card information as well. Plus, Surfshark helps you get the best price when shopping online. Websites usually show you prices based on your location, especially when it comes to flight prices. Surfshark helps you get the best deals, which means I can make the most out of my very small research travel budget. I also love that Surfshark has an antivirus software as well, so it'll just help shield all my devices from viruses, malware, and ad tracking. Look, there's no risk in trying Surfshark because they offer a 30-day money-back guarantee, so why not try them out today by heading to surfshark.com/Dr. Becky, or you can click on that link in the video description down below, or use the promo code Dr. Becky and you'll get 4 additional months free on your subscription, which is a great deal for you all. So a big thanks again to Surfshark for sponsoring this video and protecting us all online. And now let's come back down to earth and chat about what's been happening in space news in the past month. All right, first up, let's have a bit of fun, because this month it was April Fool's, and it's become a bit of a tradition now in the astronomy community to post some, funny, tongue-in-cheek research papers to the Astronomy preprint server archive on the 1st of April. So let's have a look at a few of my favourites. I particularly enjoyed this one on promo plots, in which the authors pointed out that many plots in scientific papers have wasted space, which could instead be used for advertising purposes. As both a scientist and a YouTuber, I'm just annoyed I didn't think of this myself, to be quite honest. Then there was this paper on cateroseismology, which is a pun on astroseismology. It's the study of the interiors of stars from all of their pulsation modes. Here instead, though, the author is applying this to try and better understand cats through direct detection of their purr modes. Then there was this paper on the Wazowski configuration, which modelled X-ray data from pulsars using a model of the face of Mike Wazowski from Monsters, Inc. Then we also had a follow-up paper in this year's round of April Fool's papers. So I don't know if you remember this from last year, which was called pasta markers, which was a Python package allowing you to use pasta shapes as data points on your plots. Well, now they've released Pasta Markers 2, where the pasta shapes are filled and so can be coloured with your new pasta sauce related colour scheme so that you can have a third axis on your plots, which is just molto bello. And of course, we have to talk about the two perfect Taylor Swift themed April Fool's papers on the Astronomy archive this year. This one, which mapped the eras of the universe's evolution to the eras of Taylor Swift albums. I approve. And this one, which analyzes the number of astrophysics mentions across each of Taylor's albums, splits it by field within astronomy itself, and then shows how the number of astrophysics references is increasing as a function of album number. Which I can't help but come to the conclusion that Tay-Tay is a space nerd, just like the rest of us. I also particularly love how this paper ended with, "We are never, ever, ever getting published together." Perfection. All right, moving on to all of the JWST news for this month. For those who missed it, I actually had a research paper published this month looking at featureless disk galaxies in the early universe in JWST data. I made a whole video explaining that one. If you want to check it out, I'll link it in the video description down below. But now here, let's chat about the thing that everybody has been asking each other in the astronomy community this past month. Did you get JWST time? With the announcement of these successful Cycle 4 proposals for JWST. So this was the announcement from NASA over which proposals are actually going to get time on JWST in its 4th year of observation. So everyone's had to go through this process of writing a big research proposal to be like, this is why I want to use JWST to do this really cool science. Here's all the things that we'll learn and why it's important. And here's why you should give me time to do this over anybody else that also wants time as well. So all those scientists that wrote those research proposals were informed a few weeks ago, and now the big long list of successful proposals has been made public. I'll pop a link in the video description down below if you want to scroll the list yourself. But here's a few that caught my eye. So first on the exoplanet side of things. So, planets in orbit around other stars in our galaxy, the Milky Way. There's a few proposals that are aiming to detect an atmosphere on a rocky exoplanet for the first time. Like this one, for example, for 55 Cancri E, which is 40 light years away, or this proposal to observe LTT 1445AB, which is 22 light years away. Then there's the efforts to try and take a direct image of exoplanets in orbit around their star. Like this one, for example, which is going to see if there's any planets orbiting Sirius B, a star almost the same mass of the sun, which is just 9 light years away. But as of yet, we still do not know of any exoplanets that are orbiting Sirius B, which is weird. It seems like most stars do have planets in orbit, so hopefully they're there. Then from the galaxy side of things with proposals, as always with JWST, there's always people that are going to be trying to break, the distance records of like the most distant galaxy known. Thankfully, my video I made on that is still not out of date just yet, but I don't think it's going to be very long until it is, especially with these two proposals to follow up on galaxies that have been spotted in images that are so red, we think they must be incredibly distant, but we just need to get a spectrum of those galaxies to confirm that. That's where you take the light from a galaxy and you split it into its rainbow to get like a trace of how much light of each wavelength we actually receive. And with that, you can pinpoint how much the light has been stretched by traveling through the expanding universe, something we call redshift. There's also a few proposals following up on JWST's little red dots discovery. So these are distant objects which are as yet unexplained. There's still some debate about whether they're growing supermassive black holes or supercompact starburst galaxies. So this proposal is going to monitor some of them to check whether the light from them is variable, in which case they're most likely growing supermassive black holes in the early universe, because that process is very turbulent and will cause a lot of variation and flickering. And then there's this proposal which is going to do a full census of their properties so we can really try and understand these objects better. Then of course there's the cosmology side of things. So of course there's a lot of proposals that are aiming to get a much more accurate measurement for the current expansion rate of the universe, known as the Hubble constant, or H0. This is all part of the crisis of cosmology that I've talked about many times on this channel before. So I'm sure you're all as excited as I am to eventually see the results published from this proposal from Wendy Friedman and Barry Medor that's going to give us 4 new independent measures of the Hubble constant. But then also there's this proposal as well that's led by Brent Tully that's focusing on understanding the systemic errors that might be contributing to the crisis in cosmology. That was just a small handful of the 243 successful proposals in this cycle, so lots of great science to come, and I can't wait to report on it all for you on this channel in the future as well. Now those were what's known as general observer programs that go through that sort of yearly cycle of applying for time and waiting to find out if they've got time and then waiting to get the data. But the team at Space Telescope who manage JWST also keep some time back for any unexpected things that do crop up that are very time sensitive that we need to observe right then and there. Things like supernova or novae that go off, but also asteroids, which is exactly what JWST did this month when it observed the asteroid 2024 YR4. Now, we've been talking about this for a few months now after this asteroid was discovered back in December, and the initial observations gave it a very small percentage chance of impact with Earth in 2032. Now, thankfully, with more and more observations of this asteroid, we now understand its orbit a lot better, and when we plot things into the future, we now know that it is not going to be a danger to Earth at all. But if you remember from last month's Night Sky News video, I did say that there was still a small percentage chance that it could impact with the moon, which again wouldn't be anything for us to worry about. It would just be a spectacular show to watch. Now, in the time period where we thought there might have been a chance of impact with Earth, JWST observations of 2024 YR4 were scheduled for early March, making it the smallest object targeted by JWST to date, and one of the smallest objects to ever have had its size directly measured. It was observed with both the NIRCam instrument on board JWST, which detects short wavelength infrared light, so that's going to be sunlight that's reflected off the asteroid's surface, and then also the MIRI instrument on board JWST, which detects much longer wavelength infrared light, which is what's thermally radiated by the asteroid just from its own internal heat. Both of these observations are incredibly useful because with them we can get a much better idea of the asteroid's size than we can ever get with ground-based telescopes. And it also tells us how reflective the surface of the asteroid is and therefore what it's made of. So thanks to JWST, we now know the asteroid is 60 meters across. Previous estimates put it around about 40 to 90 meters. And if it was a threat to Earth, then the size would be really key information that we need to know, because then we'd know, okay, well, if we say, sent a mission to try and deflect that asteroid from a path that would have it impacting with Earth, like was tested with the DART mission very recently by NASA, having the size means you'd know, okay, how much energy do I actually have to impart to the asteroid to be able to change its trajectory so that it wasn't a threat to Earth. Then the reflectiveness of the surface is also really important as well, because that can actually also have an impact on an asteroid's orbit. You've got particles of light from the sun impacting with the asteroid that transfers energy, and it's enough that it can actually mean that, if we don't take that into account in our models of the asteroid's orbit, then our models are going to be really inaccurate. So understanding that better would have been key if there, still was sort of all up in the air about whether it was going to impact with Earth. So thanks to these observations with JWST, we've refined the orbit again, and now the chance of impact with the moon in December 2032 has actually gone up from the 1.7% that it was estimated back in the end of February to 3.8% thanks to this new JWST data. I have really got my fingers crossed for this one that it will actually impact with the moon, because that just feels like a once in a lifetime, heck, even like a once in a millennia chance of seeing something like that. An asteroid hitting the moon? Oh my gosh, that would be the coolest thing ever. Next up in JWST's very busy month, though, is that JWST has seen aurora on Neptune for the first time. This is a big deal because we had hints of there maybe being aurora on Neptune during the Voyager 2 flyby back in 1989. And since then, we've detected aurora on all the other gas giants of Jupiter and Saturn and Uranus. And despite the fact that a load of models of the atmosphere of Neptune predicted there should be aurora on Neptune, it had remained elusive. So aurora, or the northern lights as they're commonly called here on Earth, occurs when high energy charged particles from the sun interact with the planet's magnetic field and get funneled down to the magnetic poles of the planet, where they impact with atoms in a planet's atmosphere, which glow with a really specific colour depending on the atom. So oxygen, for example, glows with a bright green colour, nitrogen with like purplish blue colours, giving us those spectacular colours of the northern lights, the aurora that we see here on Earth. The gas giant atmospheres, though, are made from mostly hydrogen and helium, which again glow with very specific colours, but this time in ultraviolet and infrared light that we actually can't see with our eyes. So with JWST, we have a hope of detecting any of the infrared aurora that might be present on Neptune, which is what Mellon and collaborators have done this past month, searching for the glow of the trihydrogen cation molecule, so H3+. So that's 3 atoms of hydrogen all bonded together, but just missing one of the electrons, so it's positively charged overall, which is why it's a trihydrogen cation. And if you have a high energy particle that comes in from the sun, impacts with that trihydrogen cation molecule, it can absorb some of that energy, transfer some of that energy, causes it to vibrate, and then give that energy back out in a few specific colours of infrared light. So Mellon and collaborators managed to get a spectrum of Neptune using JWST, again, where you split that light to get a trace of how much light each colour you receive. And within that data, they spotted that telltale signature, the fingerprint of light emissions from this H3+, which let us know that it's there in the atmosphere of Neptune. The next thing that they can then do with that data is then, map on the face of Neptune, okay, where is this emission actually coming from, where you have these specific colours from trihydrogen cations. So here is that data as an intensity map. You've got 2 shown here at different longitudes, so different sides of Neptune as it rotates. Yellow colours mean more emission from these H3+ ions, more aurora basically, and then purple means less H3+ emission, no aurora. What you can then do is then take that intensity map and overlay it on a, normal color image of Neptune, like what you'd see with your eyes, taken with a visible light telescope, like the Hubble Space Telescope. And here's what that looks like. This is the data visualization that was shared so widely by NASA. So the cyan colors here are the H3+ emission, where you've got lots of aurora. And just to reiterate, you wouldn't actually see this with your eyes because our eyes aren't sensitive to the infrared light that JWST is, which is what the aurora is glowing with here. What's cool though, and what you might have noticed already, is that the aurora is sort of like a splodge in the middle of Neptune, right? They are not at the poles like here on Earth, at least not the geographic poles that Neptune spins around, but the aurora are around the magnetic poles of Neptune. So just like here on Earth, the magnetic North Pole does not line up with our geographic North Pole. And that's because the moving charged particles in the liquid core of Earth that actually generate our magnetic field, they're very turbulent, they slosh around a lot, and actually the magnetic North Pole will drift. That's also why when you see the auroral oval maps of where the aurora are going to be visible tonight on Earth, they're not centered over the geographic North Pole. They're always skewed to be over Canada because the magnetic North Pole is over that way. Similarly for Neptune, the magnetic North Pole is actually offset by 47 degrees compared to its geographic North Pole that it spins around. If that was true for here on Earth, the magnetic North Pole would be somewhere like back smack in the middle of France, or somewhere like Seattle's latitude, which would mean the aurora would be visible in the tropics. This is why when we look at this image of Neptune, the aurora just splodge right there on the face of Neptune rather than up at the poles like we're used to seeing, not just for Earth, but also for the other gas giants too. And finally, speaking of hydrogen emission, we now turn to the most distant detection of glowing hydrogen that's ever been made, with this paper published by Whitstock and collaborators, who using JWST have spotted a bright spike of hydrogen emission from a galaxy that we're seeing just 330 million years into the universe's history, and this is a big deal. Not because it's the most distant galaxy that has ever been found. There's a few more that have been found at slightly further away, like at redshift factors of 14 rather than 13 like the one here. Redshift is a measure of how much the light has been stretched out by the expanding universe. So it tells us, how long has the light been traveling through the universe, and therefore, okay, how far away is that galaxy and how early in the universe's history are we seeing it when we detect the light from it. And this is a big deal because we shouldn't be able to see this glowing hydrogen that early on in the universe's history. So in the early universe, after everything had cooled down after the chaos of the very early universe, all you had was a load of neutral hydrogen gas. So 2 atoms of hydrogen bound together, H2, which is great because that is the fuel that you need to make stars, and the first stars were born out of that. But the problem with H2, neutral hydrogen gas, is that it is opaque. It does not allow light to penetrate through it. So in the early universe, you just had this sort of like fog or haze that blocked a lot of the light. It was only when the first stars formed and started giving out ultraviolet light that when it impacted with one of these H2 molecules could split it apart and also ionize it. So separate it into just your positive hydrogen atom nucleus and then a free electron, that the hydrogen gas then became transparent and light could actually penetrate through the hydrogen gas of the universe. We call this period of the universe's history reionization, when the universe went from opaque to bubbles of clarity around newly formed stars until the whole universe was eventually transparent to light after about 1 billion years or so. And because of JWST's massive mirror and light sensitivity, the hope was always that we could pinpoint when this reionization process started, when we first started to detect emission of light through this fog of the early universe. Specifically emission from hydrogen itself. The hydrogen that didn't quite make it into the stars, but is still surrounding those stars, and when it gets hit by ultraviolet light, it glows with a very specific color or wavelength of light in the same process that causes the aurora. And we call this hydrogen emission Lyman alpha emission. But crucially, only once that reionization process has happened could that Lyman alpha emission actually pierce through the fog so that we could detect it. And here we have a galaxy with a stonkingly bright Lyman alpha emission peak that we're seeing when the universe was just 330 million years old, not 1 billion years old, which is originally when we thought reionization would finish. This really put the cat amongst the pigeons, because to be able to see this, there must be a very large bubble of ionized hydrogen surrounding this galaxy. And to get that at this time in the universe's history, when it is still very young and we think the first stars have only just formed, then you can only get this with one of two things, right? Either you have got a very weird and very hot and very massive collection of stars that is giving out so much more ultraviolet light than the stars that we see forming today. Or you've got a growing supermassive black hole, which is accelerating material around it to huge speeds so that it glows, and then it's the energy from that material that can then ionize the hydrogen in the bubble. But that would have to be a very massive black hole to do that. And again, how do you get a supermassive black hole that early in the universe? Either way, there's something we don't understand here, right? Either there's a weird population of stars that we've never come across anything of its like, or there's a supermassive black hole that shouldn't exist yet, right? It shouldn't be that big just 330 million years into the universe's lifetime. Once again, just adding to that pile of things that JWST has shown us about the early universe that don't make sense yet. At least not on their own, anyway. Because hopefully with time and with more analysis and with more science, we'll start to pull together those individual pieces of the puzzle that don't make sense on their own, until a coherent big picture of what's going on in the early universe starts starts to appear. All right, that's it for Night Sky News for this month, except to tell you that I have some new merch. I'm currently wearing my new JWST Planets shirt. You're probably thinking, planets? Planets? What planets? You've just got this cute little JWST logo on the front, but bam, on the back, it's the gas giant planets of the solar system as seen by JWST, and they are to scale with each other as well, which I absolutely love. We've also got this one celebrating the most iconic space telescopes of the past few decades, from Hubble to Planck to the recently retired Gaia mission. Euclid also makes an appearance on there, and without fail, whenever I make a video about Euclid, one of you, or maybe even 10 of you, will make the great pun of "here's looking at Euclid," which riffs off the famous line in Casablanca, "here's looking at you, kid."
He's looking at you, kid.
So obviously I had to put that on a shirt as well. I love this one because we also have some Euclidean geometry space in the background as well, you know, for all the super nerds out there like me. And finally, if you prefer a more minimal style of a tee, we have this classic list of space agency names, right? We've got the US's space agency, the European, the Canadian, the Japanese, and the Indian space agencies all listed. The link is in the description to grab either one of those that tickles your fancy, along with my original merch designs as well that also are still available. Pip likes the merch too, don't you? You like to put your hair all over the black t-shirts. Yes, you do. Anyway, as always, if you spot any space news stories that you want me to explain in a future Night Sky News episode, or if you snap any pictures of the night sky that you'd like to share, then tag me over on social media. I would always love to see them. But until next time, everybody, happy stargazing. And you spot a shooting star, I don't remember what month it was then. Actually informed, you know, a few weeks ago. They were yeeted out a few weeks ago, those emails. And see those, you know, the molto bello. I'm not sure if I'm saying that properly, but molto bello. You can correct me in the comments, all of you Italians. But that would have to be a very massive black hole to do that. Then there's also efforts to detect the Looney Tunes called. That was just pit pet. The distance record. This is covered in pit. I have worn it once. Hey, where are you? Help yourself a minute. Say hi. No. Okay.